Good morning, team and family. Today is April 2nd, 2020, and it is a terrific Thursday. It is a great day for learning. Right, so today we are going to continue our investigations and learning about the scientific method. I'm going to go on and share the screen. All right. Um, we're going to go to Google Classroom. Remember that we do need Google Classroom open in addition to the video. Right. So I'm going to use Chicago State today. And from there, we'll go to classwork. We'll look for the topic scientific method and look for the date. It's the last one that I have posted. Also, if you look in Notre Dame, I have the same link under scientific method. And then if you go to Michigan State, classwork, scroll down to scientific method, have the same thing as well. All right, so let's go back to Chicago. Okay, we'll click classwork again, scroll down to Thursday, April 2nd, 2020, and here we are. All right, now another way would be through the stream. You would just find the last post, and it will be this one, and it'll take you directly to the assignment as well. All right, so today, first, we're going to practice in Quizlet. One of my parents expressed to me that it would be easier if I wrote the steps out for those visual learners, and I agree. And so, because hearing me say the steps is great for the auditory learners, and then seeing me is great. Great for those, well, see me actually doing it and doing it with me is great for those kinesthetic. But then there are some people that are visual and they need to see the actual steps laid out in front of them. And so that's why Ms. Davis actually typed it out as well. All right, so first we're going to go to Quizlet to just practice and kind of get those terms in our mind. So I see you, Khalees. All right, so in Quizlet, I did create the classroom. I give a shout out to several scholars that got on Quizlet and almost beat my score, but not quite. So it's coming because I see you grow. All right, so again, we have been working on learning the different steps in the scientific method and process. And the scientific method and process is a series of steps that scientists use to answer questions and to solve problems in the real world. All right, so a problem, you identify that there is a problem by using your five senses. And that we call that observing. We call it observing. The problem is always in the form of a question, and it's the question that we're trying to answer by doing an experiment or an investigation. And remember, I like to call them investigations because every investigation is not an experiment, but every experiment is an investigation. So we have to first identify that there is a problem. Ms. Davis likes green tomatoes, and I've been using that scenario all week. And I would like the largest green tomatoes that there is. And in order to get those large green tomatoes, I've got to figure out how to make them grow, larger. All right. And so I have to come up with a hypothesis. And a hypothesis is how I'm going to make my large green tomatoes, make my tomatoes grow larger. So a hypothesis is an educated, testable guess. It's a testable possible explanation to the problem, usually in the form of an if-then statement. So with my green tomatoes, I conducted 3 investigations this past summer, and I'm so ready to grow more tomatoes, but I'm gonna wait, just gonna wait, because it's not necessarily the right time. I got a few more weeks. But what I said that if I'm hypothesizing, if I plant my tomatoes in the sun and I give them fertilizer, maybe a certain amount of water and a certain amount of sunlight, then they will grow into be large and succulent. So that is my hypothesis. All right, the procedure is the steps that I take in my entire investigation. So it's the plan for how I will conduct my experiment or my investigation. And when we plan things out, we need to write down our plans. Um, we don't want to go off the top of the head, off the dome. We actually need to write our steps out because sometimes your procedure or your plan has to change, especially if your hypothesis, if you learn that your hypothesis is not actually testable or your results are inconclusive. Right. So then the experiment or the actual investigation part, now that doesn't, when we think of experiment, traditionally we think of blowing things up. Yeah. Mentos and Coke. But again, an investigation could be watching videos, it could be watching behaviors, it could be watching animals cross the street over and over and over and over and over again, watching the same animal cross the street over and over and over and over again. It could be you walking into the kitchen and watching your parent and just staring at your parent and seeing how they're going to react and then documenting how they're going to react by you just sitting there staring at them like this and not saying anything to them like this. You're probably not going to get the reaction that you think you're going to get. However, each time you conduct that investigation, you write it down. And so, again, an experiment is not necessarily an investigation. Well, let me take that back. The investigation is not necessarily an experiment, but an experiment is an investigation, right? And let's go back, make sure we got that. It's when you test your hypothesis, you may need to do this step more than once to see if the results are the same each time. Again, we're looking for consistency. If your results are the same, then you know that your hypothesis, what you guessed, may be correct. If it's not the same, you may need to go back and you may need to change your hypothesis, right? And so then the next would be the control group. Now with my tomatoes, Miss Davis loves her green tomatoes. I'm telling you, I'm ready. The season is almost here. I am ready to get out there and to plant my tomatoes. However, there will be two different groups that I will have. I will have one as my control group, and the other will be my experimental group. Now, my control group is the group where everything is the same. It says part of the experiment that does not contain a variable, all conditions are kept normal, used as a standard for comparison. So in my control group, I'm going to have the same seeds, just one basic type of tomato seeds. I'm going to have one type of potting soil. I'll have one type of pots, the same type of pots that I'm going to use. I'll probably use like little pods. And then once they get larger, I'll transfer them from the little pods and I'll actually put them in actual soil. And then I'm going to use water. I'm going to water my plants the same time every day. The only thing that would probably affect whether or not my plants get a different amount of water would be if it rains. So that's my control group. That group, nothing changes, everything stays the same. I'm not adding any variables, I'm not changing anything. It's just going to be my standard. I'm planting tomato seeds, boom, they pop through the soil, woohoo, flowers, and then all of a sudden I got fruit. So that's going to be my norm. But then in my experimental group, that's going to be the group where I have an actual independent variable. And my independent variable is going to be the factor in the experiment that I change on purpose. And in this case, I'm going to use fertilizer. And I like the sticks, but I think that I'm going to use the liquid fertilizer this time because I don't have to worry about them melting and being absorbed through the soil. So I think I'm just going to use the liquid fertilizer where I just put them down and they're automatically absorbed through the roots of the tomato plants. So in my control group, I'm not going to use any fertilizer. But in my experimental group, I'm going to use the liquid fertilizer. And that will be the independent variable that I change, which would also be known as the cause. And then the result or the effect of my independent variable will be the dependent variable. And the dependent variable, again, would be the size of the tomatoes after I've conducted my entire investigation, after they've grown, after I planted them, they blossomed. I now have my green tomatoes, which will eventually become red, but mine won't make it red because I'm going to use them before they get ripe. So anyway, the dependent variable would be the effect. So the independent variable is the cause, and the dependent variable is the effect. All right. So once I record the diameter of my tomatoes and the color, whether or not they actually grew in my experimental group, if they got large and succulent, if they were where I needed them to be to make my chow relish or to fry my green tomatoes, all of that information, the size of them, the color, the appearance, I'm going to record that as my data or my data. Data. Either way, the information that you organize into charts, tables, drawings, and diagrams, you can decide what the information means. I've got to analyze my data. I'm going to take all of this information and I'm going to be like, I did that. I planted those. They grew based on what I did. Or I'm gonna be like, man, something just went wrong. I just I'm gonna do it again. So I'm just gonna take all of the information that I gather and then I'm going to move accordingly. All right. And then the next, after I gather all this information, after I analyze it, 9 times out of 10, I'll be eating my fried green tomatoes while I'm doing my conclusion. Yeah, just like that, just like that. So I'm going to conclude that my hypothesis was accurate or it was not accurate. If it wasn't accurate, then I got about another month and a half before tomato season is no longer amongst us. And more than likely, Miss Davis is going to plant a couple of more tomatoes. I mean, tomatoes. Um, but if my hypothesis after I tested and what I stated does indeed come out to be true, then it becomes a theory. If I add fertilizer, liquid fertilizer to my tomato plants as they are growing, then they will produce large, succulent fruit. Then it becomes a theory. A theory is a scientifically acceptable general principle or body of principles offered to explain a phenomena. My phenomena is, oh my gosh, my tomatoes grew large. I mean, they are grande, muy grande. They're big. And so I will declare my hypothesis to be true. It's a theory. I want you to continue to study these vocabulary words, become familiar with them, because as the weeks progress and as we continue to do the virtual learning, you're going to hear those words. And Ms. Davis will always circle back to them. But without further ado, let's play the match. Shout out to Aiden, shout out to Khalees, shout out to Dayana, shout out to Talia, shout out to Angel, shout out to Christian, and there was someone else, Asia and Adrian Reed. Shout out to you leaders. Miss Davis noticed that you were online, but somebody still didn't beat my score. I'm gonna try to beat my own score. Let's see. All right. I know that the educated test, I messed that up. Okay, the plan, how, oh, that's my procedure. I think that's my procedure. Okay. Always in the form of a question. Where is my hypothesis? I don't see it. It's in the, oh no, that's the problem. That's the problem. Boom. A scientific expected general person of theory. No, it's a principle offered to explain a phenomena. That's a theory. I don't see my theory. It's a, okay. I'm mad now because I don't see it. Because I don't see it. And I know it should be here. It's a theory. It's a, I know y'all saw that. All right. So the fact of the changes, that's the dependent variable. And then independent. I am mad. I am mad. I'm going to play it again. I'm going to play it one more time. I'm going to play it one more time. I got to get it. I got to get it. I got to beat my score. I did not beat my best score. All right, here we go. Let's see. All right. A series of steps that scientists take with the scientific method. Okay. The information, that's the data. Uh-huh. An educated, testable guess. Ooh, that's my hypothesis. Okay. Test your hypothesis experiment. Uh-huh. The answer to your question, the summary. Okay. No, that's not it. Okay. There it is. Conclusion. And then my control group. Boom. 25 seconds. All right. So I'm not going to play it again, but I am going to go back to Quizlet. All right. So then let's go back to the classroom. All right. So when we go back to our classroom, we just practiced our vocabulary. We just got that practice in. Our brain is good. All right, so now the next thing, all right, we studied the terms, we played the match game. We're gonna watch the YouTube videos. There are 4. Okay, there are 4 videos. They're all right here. So let's start with why is Dubai so hot? This one is 3 minutes long, and all of the videos are not long. They're like 3. That's like 9 minutes, 10 minutes, like that's not long. All right, so let's watch the video. And then after we watch the video, I have a Google form down here. I think there's only like 3 questions maybe. And you'll just answer the questions based off of the videos. Now, I'm not gonna do the answers for you. I'm just telling you that there's a Google form here for you to answer the questions. But just in case some of us can't go to YouTube, Miss Davis is totally gonna watch the YouTube videos here. All right, let's go. Why is Dubai so hot? And you can open them up in your own, in another browser if you want to. I'm just gonna watch them here for the sake of people that can't access YouTube. All right. See if I can turn it up. It's good and loud.
So why is Dubai so hot? The obvious answer is we're in the desert. But the real answer is actually a lot more complicated. Let me explain. Dubai is a city of the United Arab Emirates, which sits on the Gulf Peninsula. It won't take a geographer to figure out that that means it gets
Hot.
very hot. Yes, Dubai is a desert city.
Ooh, it's beautiful.
From a practical perspective, that means the city has 2 seasons: hot and very hot. During the winter months, it gets up to around 22 degrees Celsius. That's around 70 Fahrenheit. During the summer, it gets far, far hotter. Yes, as it gets the hottest part of the summer here in Dubai, which is around July, August, it can hit temperatures upwards of 49 degrees.
Woo!
20 degrees Fahrenheit.
That's hot.
That is seriously amazingly and searing hot. Now, from a practical perspective, that means one thing. When it hits summer in Dubai, no one really goes outside. That's why all cars, houses, and malls here have serious air conditioning. A lot of the workers here will retreat back to the cooler home countries, and the people who do stay spend less time on the beach and a lot more time on the sofa. But why does it get so hot here in Dubai? The city sits on the same latitude as places like the Bahamas, Bangladesh, and Taiwan. Those places don't turn into sweat boxes come the summer. So what's the difference between this place?
Good question.
The reason why Dubai gets so hot compared to those other places is down to one thing, or lack thereof: clouds.
Yeah.
Yes, clouds are those amazing puffs of precipitation that block out the sun, trap in the rain, and generally look like marshmallows up in the sky. Dubai sits in a high pressure zone, and winds tend to flow from high pressure superground, meaning the ground more easily absorbs the heat. And the hotter the ground gets, the hotter the sphere gets. So how does this map compare to those other places that sit on a similar plane to Dubai? Well, every somewhere down in the Caribbean and Southeast Asia, there tends to be which increases moisture and, you guessed it, those ever important clouds. And there you have it. Dubai is so hot not because it's in the desert, but because of its stink lack of clouds. Those same clouds that turned it into a desert in the first place.
Right.
The living experience foolishness. That's all from Please do hit subscribe for another video.
All right. So that's the first video. I'm going to close this one back out and we're going to go to the next one. So we want to know why it's so hot. It's so hot because of, yeah, I know you said it. It has no clouds. They're lack of clouds. They have clouds, but not enough clouds to cause rainfall and to change the temperature. But let's see. Here's our next video.
UAE is one of the driest countries on earth, and annual rainfall might be hundreds of millimeters. As a result, it has to get creative when it comes to finding solutions. However, in the early 2000s, the UAE started performing regular cloud seeding operations. Cloud seeding is the process of increasing the amount of rainfall produced by clouds. Some of these clouds are neutral, sometimes clouds, for example, only 40 to 50% of its rain versus in the cloud comes out rain. So by these operations, we try to increase this amount of rain, for example, from 50 to 80%. So how does it work? It starts here inside the National Center of Meteorology, where a team is constantly monitoring forecasts, looking for potential clouds to see. The operations only work with cumulus clouds, which are vertical in shape. Once they spot a cloud, they radio the pilots. They take the air off with hygroscopic flares filled with a mixture of potassium chloride, sodium chloride, magnesium, and other materials. It's essentially salt. When the plane reaches the right clouds, the pilots release the flares. These salts basically attract the moisture and try to make it condense. So it's a condensed particle. And look what happens here. And then when these particles condense, they hit each other, and then they form a bigger droplet that cannot propagate downward. So salts in 2017, UAE performed 242 cloud seeding operations.
It's a lot.
The government is confident the operations are increasing the amount of rainfall, but it's difficult to gauge. Until now, there's no way that you can measure the census rate or increase detected whether the clouds are the same. But you don't know, for example, before actually seeing the cloud, you don't know itself or not like that happens. The country is also estimated in research that enormous dollars in random, innovative researchers and projects.
Awesome. All right. So I learned a cool fact that China also has certain areas where they do not have a lot of rainfall. And so what they've done in those areas, they've planted seeds and they are doing the cloud seeding where they planted the seeds in the actual soil and then they're watering the seeds with the clouds through the cloud seeding. And so now they have more trees and plants in those areas. So that's pretty cool. It's something that we can do in the near future to increase the vegetation, the plant life. All right, so let's look at this next video. This one is just another video that talks about cloud seeding as well. And it just shows you cloud seeding. So I'm actually gonna silence it. And so what he's doing is he's flying and he's finding the perfect spot to release his heat. And when he releases the heat, it causes the water to change its state of matter. And then as it gets away from the heat source, it condenses, becomes heavy, and then it causes the rain. But you could actually see the flames coming from the back of the jet. It's kind of loud, so you see the flames right here coming from the back of the jet. So they have to find the perfect clouds to actually seed to cause the clouds to rain. Now, what's even more fascinating is when they have a cloud producing machine, a machine that actually produces clouds. And what's even more fascinating is when they use the machine that produces the clouds. And this is what they're working towards. They're working towards taking those machines that produce the actual artificial clouds, man-made clouds, and the clouds are in the sky. And then they take heat and cause the clouds to change its state of matter. And then once it condenses, once it cools off, then it's more moisture accumulating because there's already moisture in the atmosphere. So you're heating the moisture that's already in the atmosphere, and you're heating the moisture that's in the artificial clouds. And then add all that moisture together, then cause it to condense, then it's going to start raining. So that's one of the ways they're trying to create artificial rain through man-made clouds. All right, we have one more video, and this one is about the problems with cloud seeding. So it's a benefit, you can make it rain. Then there are some problems. Let's see.
Wash away some of the soot and so much. So the idea of cloud seeding has been proven. But what exactly is cloud seeding? Cloud seeding refers to the transformation of clouds into rainfall with the use of appropriate chemical seeding agents in the volcanic change in the microphysics of the clouds so that it can create a desired response, which is basically the rainfall. Dr. Raja said that cloud seeding is used in countries such as the United States, China, and Russia, where they try to create rain for agricultural purposes.
Right.
Just last week, Indonesia said they would use cloud seeding to help ease the forest fires in Sumatra. But before cloud seeding can be carried out, there must be clouds in the air. Cloud seeding is not about creating clouds, but drawing more moisture into the cloud. Once moisture is gathered, the water droplets combine together. When they become too heavy to be transported to the air, they fall to the ground as rain. So how is it done? One of the most commonly used delivery methods is via aircraft. Existing clouds need to be identified as suitable for cloud seeding, especially after the plane has to fly to the clouds and release the chemicals, usually silver iodide or calcium chloride. The plane has to release the chemicals at different altitudes. The chemicals released into the atmosphere act as a nucleus for moisture to gather. When enough moisture has gathered around the nucleus, it becomes too heavy and falls to the ground as rain. If done right, cloud seeding typically yields an increase of 5 to 20% more rainfall. But Dr. Raja pointed out that cloud seeding is not risk-free and that more studies need to be done on its long-term effects. So based on the knowledge that we have theoretically, what would be tempted to say is like, cloud seeding may be successful, but because it's extremely cautious, we are big with Mother Nature.
Right.
Okay. And so Mother Nature, as we saw in the debate, has its own characteristics. And so you cannot sort of do geoengineering. Okay. When you try to do geoengineering, it has its own impact. And according to what is known in textbook, silver iodide is considered to be a hazardous chemical. It's also toxic, to animals, to humans, and also to overall ecosystem as such, particularly fish. And so what we don't know at this point in time will be the short-term or long-term negative impacts of chemicals like silver iodide on humans and on fish and also livestock. But we are talking about biomagnification. Okay, so if a small microorganism, a small organism medicine, ingestion is going to, then it could lead to, bigger effect across the food chain.
Yeah, so he said that smaller organisms, if they ingest these chemicals that they're using in the sky with the cloud seeding, then it could cause problems or cause a interruption in their particular food chain. So, like the sharks that eat the fish and the fish that eat the planktons or whatever other little tiny organisms that are in the marine biomes. So if we take out the fish that are um, eating the plankton, if we take out those fish, then there may be an overgrowth of plankton and other little microorganisms. But then also because we're killing the fish with the chemicals, then the sharks can also be killed because they're starving because they don't have anything to eat because all of the fish are dying. So that's what he's saying where it could affect the food chains. Let's finish it up real quick.
Some have noted that item toxicity in summary, the National Environment Agency said in a statement to reason that they have never attempted toxicity and that they are currently no plan to do so. They said the small size of Singapore and the variability of winds also mean that the induced rain, if any, may not fall directly over our island. In any case, the rain will provide only temporary relief as the smoke haze would continue to be blown towards Singapore by prevailing winds. Should the fire in the region continue to persist, for these reasons, we have no plans to conduct cloud seeding, but we will keep the option open.
Get tequila. All right. So, all right, we'll stop right there. Okay. And then after you watch the videos, I want you to go to the Google form, and on the Google form, I want you to answer these questions. And then if you have not answered your ReadWorks, then I want you to sorry. If you have not answered your ReadWorks questions, I do want you to click the link to go to ReadWorks and finish your ReadWorks, all right? And you just log in using your student account through Promise Academy and your password as well. And then make sure again that you answer the 3 questions in the Google Forms. They are open response, short answers. And then please, again, make sure that you do the questions in the ReadWorks. All right. Okay, we're gonna stop sharing the screen. Now, so that is it for today, my awesome, fabulous fourth graders. Make sure that you practice the vocabulary words in Quizlet. Make sure that you are doing your ReadWorks, and then make sure that you watch the videos and answer the questions in Google Forms after the videos. If you have any questions, your teachers and myself are here for you from 9 o'clock to 3 o'clock. And I prefer you use Dojo. You can email me. You can leave me a message in the thread. Totally fine. That's it. Have a wonderful day. Promise.